आज ही डाउटनेट ऐप डाउनलोड करें। डाउटनेट पर होगा अब आपके सभी मैथ्स, केमिस्ट्री, फिजिक्स और बायोलॉजी डाउट्स का सफाया। बस अपने क्वेश्चन की फोटो खींचो, उसे क्रॉप करो और तुरंत वीडियो सोल्यूशन पाओ। डाउनलोड नाउ।
Let us discuss the given problem. We have been given two statements. First statement says that sum of the series 1 cube minus 2 cube plus 3 cube minus 4 cube plus 5 cube minus 6 cube till 11 cube is equals to 378. And the second statement says that for any odd integer, that is n, which is greater than or equal to 1, n cube minus of n minus 1 whole cube plus so on till minus 1 to the power n minus 1 into 1 cube is equal to 1 by 4 into 2n minus 1 into n plus 1 to the power 2. Right. So first of all, we are considering statement 2 here. So let us write down statement 2, which is equal to n cube minus of n minus 1 whole cube, and this is plus and so on till this is minus 1 to the power n, and this is 1 cube, and that should be equal to 1 upon 4 or 2n minus 1 or n plus 1. We have to just figure out that whether it is true or false, right? So in the next step, if we write the value of this expression in form of numerals, so that can be equal to 1 cube minus of 2 cube plus of 3 cube, and this is minus of 4 cube, and this should continue till n cube, right? So we have just written this series, but again we have just turned this series, like first term is equals to 1 cube and the last term is n cube. So right, we have written this series in this format. Now we can write this series in another way, and that can be equal to 1 cube plus 2 cube plus 3 cube plus 4 cube, and this should be continued till n cube, and now minus 2, and this is into 2 cube plus of 4 cube plus of 6 cube, and this should continue till n minus 1 whole cube. Why we have written this series and in this format? Because we know that this series, that is 1 cube plus 2 cube plus 3 cube till n cube minus of 2 into 2 cube plus 4 cube plus 6 cube till so and so on, is equivalent to this series only. Now what is the benefit of writing this series in this format? This is here because we know that we can evaluate the value of this expression. This is basically equivalent to sum of n natural cube of n natural numbers, right? And that is equivalent to n into n plus 1 upon 2 whole raised to the power 2, right? And similarly, this series can also be evaluated by using one concept. If we take 2 cube out of this common, then this would be equal to minus of 2 into 2 cube, and this would become 1 cube plus 2 cube plus 3 cube and so on till n minus 1 upon 2 whole cube, right? Now it is basically again 1 cube plus 2 cube plus 3 cube till n minus 1 by 2 whole cube. Now we can apply the same concept here also. So this is basically minus 2 into 2 to the power 3, and this is equal to summation of this time n minus 1 by 2 whole to the power 3. This is basically the concept, right? So we can put the value of n as n minus 1 upon 2 instead of n to just calculate the value of this expression, right? We are talking here about this expression. So now we shall substitute the values in the given formula. So this part is equivalent to summation of n cube, and this is basically n into n plus 1 upon 2 whole raised to the power 2. So that would be n into n plus 1 upon 2 whole raised to the power 2. Now let us switch on to this part. So this part is basically minus of 2 into 2 cube. So minus 2 into 2 cube is 8 into the summation of n minus 1 by 2 whole cube. So now we are going to put the value of n as n minus 1 upon 2 in this formula. So this would become n minus 1 upon 2 multiplied by n minus 1 upon 2 plus 1, and this should be divided by 2 whole raised to the power 2. Right, now finally we can solve this expression further. So the value of this is equals to n into n plus 1 upon 2, and this is minus of 16. This is divided by 4 because this is 2 square, and this is n minus 1 upon 2 square, that is again equal to 4, and this is basically n minus 1 by 2 plus 1, so that is equals to n plus 1 upon 2, right? So this is n plus 1 upon 2, and 2 square is 4, so this is 4, and this is n plus 1. So this is basically n minus 1 square into n plus 1 square, and divide by 4, right? So now we can just cancel this 16 with this 4, and this is the expression which is left to us, right? So we can substitute again. We can write this as, this is actually whole square, right? So we can write this as n into n plus 1 whole divided by 2 raised to the power 2, and this is equivalent to minus of n minus 1 square into n plus 1 square, right? So n minus 1 into n plus 1 whole square, and this is divided by 4, right? So we can just take these values again. This is basically 2 raised to the power 2. So instead of this, we are writing this as n into n plus 1 whole square, right? And this is equals to divide by 4. So we can take the LCM easily in this case. So the LCM is obtained as 4, and now in the numerator part we obtain this as n into n plus 1 square, so that is equals to n square plus n whole square, right? And this is minus of n, this is n minus 1 and n plus 1, so that is n square minus 1 whole square, right? So now we can further solve the value of this expression, so that is equal to n square, that n square square, that is equals to n raised to the power 4 plus n raised to the power 2 plus of 2 into n cube, and this is minus of n square minus 1 whole square, so that is equals to n raised to the power 4 plus 1 minus of 2 into n square, and this is finally divided by 4, right? So the value of this expression is obtained as, now we need to cancel this n raised to the power 4, this is plus 2n square, this is plus n square, so that is equals to plus of 3n square, right? And this is plus of 2n cube, so this is plus of 2n cube, and this is minus 1, and this should be divided by 4. Now we have to just simplify the value of this expression further. So for that, we can write this as 2n cube plus of 3n square, and this is minus 1 divided by 4, right? And this is equals to 2n minus 1 into n plus 1 whole square divided by 4, right? So let us check the second statement. This is basically 2n minus 1 into n plus 1 whole square by 4. So we can say that second statement is true. Now let us switch on to first statement. The first statement says that the sum of this series is equals to 378. So now when we have obtained the formula for this series in this way, so now we can put the value of n as 11 in this equation to obtain the sum of this series, right? So when we put the value of n as 11, so we can solve this as, this is 2n minus 1, that is 2 into 11 minus of 1, finally multiplied by 11 plus 1 raised to the power 2, and that should be divided by 4. So the value after solving this equation is obtained as 378. So finally we can write that statement 1 is also true. So statement 1 and statement 2 are both true.
क्लास 6 से 12 से लेके नीट IIT JEE मेंस और एडवांस के लेवल तक 10 मिलियन से ज़्यादा स्टूडेंट्स का भरोसा। आज ही डाउनलोड करें डाउटनेट ऐप या व्हाट्सएप कीजिए अपने डाउट्स 8400 400 400 पर।